how do you find the second derivative of f of x? Basically, the first thing you do is you find the first derivative. The second step is to simplify. And the third step is to do it again. Take the derivative again. Okay? Write down three different notations to represent the second derivative. So, you know how f dash of x is the first derivative? Well, f double dash of x is the second derivative. And y dash is the first derivative, so y double dash is the second derivative. And finally, dy dx is the first derivative. D squared y over dx squared is the second derivative. So those are three notations you can use to represent the second derivative. Two notations to represent the nth derivative. You could have f to the n, and I don't think we're going to do this too much in this class, but f to the n of x. And the other one would be d to the n y of dx to the n. All right, let's do some problems. So find the second derivative of f of x, given that, and then they give us some functions here. And so basically the first step you already know how to do is to find the first derivative. So it would be 6x minus 6, right? And then to find the second derivative, you just take the derivative of the first derivative. So you get 6, right? You can see that if you took another derivative, it would just become 0. Let's do C. The first derivative of this is going to be 6x squared minus 6x to the first minus 1. The second derivative would be 12x minus 6, right? E. First derivative would be, we're going to have to use chain rule here, 3, 1 minus 2x squared times negative 2, because we did the chain rule of the inside of that. Now let's simplify, because if we simplify, it's a little bit easier to do the second derivative. So I did simplification. Now I'm going to do the second derivative. So I'm going to do take another derivative of the first derivative. So this just stays, right? Because negative 6 is a coefficient. Then I do power rule. It comes to the first. And then I do chain rule on the inside, negative 2. And then, so I end up with negative 2 times negative 6 times 2, which would be positive 24. 1 minus 2x. I could distribute the 24, and I would get 24 minus 48x, right? Okay. All right. Now here they're just asking the same thing. They just asked with the other notation. Find the second derivative given that y equals x minus x cubed. So the first derivative would be 1 minus 3x squared. And the second derivative would be 0 minus 3 times 2x to the first. So that's equal to negative 6x. Okay. Next one. So first we're going to rewrite the y as 2 minus 3 times x to the negative 1/2, right? Because it's x to the 1/2 because it's a square root, and since it's the denominator, it's negative 1/2. Then I'm going to take the first derivative. The first derivative of 2 is 0. The first derivative of negative 3x to the negative 1/2 is negative 3 times the exponent times x to the 1 less than the exponent, which would be negative 3/2. So I'm going to first simplify that so it's easier to take the second derivative. Remember, we haven't taken the second derivative yet. This is still the first derivative. Negative 3 times negative 1/2 is 3/2 x to the negative 3/2. And then I'm going to use the product rule here. So it'll be negative 9/4 x to the negative 5/2. So what I did was I took the exponent, negative 3/2, I put it right next to 3 halves, I multiplied them together, and then I reduced negative 3 halves by 1. I ended up with negative 5 halves, right? All right, now let's do this one. This is going to require the chain rule, right? So the first derivative is going to be 3 times, oh, by the way, this is the second derivative. 3 times x squared minus 3x squared. And then we're going to do chain rule, 2x minus 3. And now we're going to do the second derivative of this mess. So looks like we're going to have to do product rule, right? So first thing we're going to do is we are going to write the 3 on the outside. And then we're going to write the first function times the derivative of the second function. The derivative of the second function would just be 2. And then we're going to take the derivative of the first function, which would be, not 6, because we removed that. 2x squared minus 3x to the first times the chain rule, which would be 2x minus 3. And then we multiply it times the second function without the derivative taken. So actually that's squared there, right? Okay. So let's see. Let's distribute now. So we'll put the 3 inside for each one. So we'll have 6x squared minus 3x squared. And then we'll have 6 times x squared minus 3x to the first. And then we'll have 2x minus 3 squared. And let's factor out x squared minus 3x. And then we'll have inside, we'll have 6 times x squared minus 3x plus 6 times 2x minus 3 quantity squared. And then we can take this and try to combine like terms, okay? So 6x squared minus 18x plus, and then we'll have 6 times 4x squared minus 12x plus 9. So that's equal to 24x squared minus 72x plus 54 minus 18x and 6x squared. 6x squared plus 24x squared is 30x squared. Minus 18x minus 72x is minus 90x plus 54. So all this is multiplied times x squared minus 3x. Yuck, huh? Okay, let's go to the next one. 3a. Given f of x equals x cubed minus 2x plus 5, find f of 2. Okay, that's very easy, right? We just substitute 2 in there. By the way, you remember how I said that IB doesn't really care about simplification? So that's mostly true, right? But like in that last problem, we had to simplify the first derivative so that we could easily take the second derivative. And we didn't have to do all that simplification on the second derivative, but sometimes they'll ask you to show that, blah, 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 and they'll ask you to make it match their end product. And if they do that, then sometimes you're going to have to do some algebra to get it to look like theirs. So that's 9, right? So f double dash of 2 means that we're going to take 2 derivatives of this. So the first derivative is 3x squared minus 2. And then the second derivative is 6x. And then we're going to put 2 in for x. So f double dash of 2 is equal to 6 times 2, which is 12. The third derivative with 2 substituted in for x. So like the second derivative is 6x, right? The third derivative is 6. So even if you put 2 in or you don't put 2 in, it's just equal to 6 anyway. Suppose y equals this expression here, and remember that the k and the a here are just constants. Show that the derivative of this function is equal to ky. Okay, so first thing we're going to do is we're going to find the first derivative, and a is just a constant, so we just leave it there. And e to the kx, the derivative of e to the kx is e to the kx, because the derivative of e to the something is e to the something. We just need to do the chain rule for what's inside, so the derivative of kx is just k, because k is treated as a number. So the first derivative is equal to ak e to the kx, right? And then we're like, okay, but actually these two pieces here are the original function. So y dash is actually equal to k times the original function. And so that's, we've just shown that, right? Show that the third derivative is equal to k cubed y. Okay, so the first derivative is equal to ak e to the kx. The second derivative is equal to ak e to the kx, and then that's the derivative of e to the kx is e to the kx, and then we also do the chain rule. So that's equal to ak squared e to the kx, and that's the second derivative, right? Let's do the third derivative. The third derivative would be ak squared e to the kx again, and then we also have the chain rule again. So it's equal to ak cubed e to the kx. And we could simplify this because a and e to the kx together are y, so it's equal to k cubed y. So we've shown that too. Number 5. Find x when the second derivative of f of x equals 0 for this function. So I don't know exactly how to do this yet, but they said to find the second derivative. We can do that pretty easily, right? So the derivative is, the function is x over x squared plus 2. That looks like a quotient, right? So we could use quotient rule, or you could use product rule if you rewrite the v, but I'm going to use quotient rule because that's most natural. So x equals, or u equals x, and v equals x squared plus 2. So u dash is equal to 1, right? And v dash is equal to 2x. Now let's substitute it into the formula, vu dash minus uv dash divided by v squared, which is the quotient rule. So we're going to put v, which is x squared plus 2, u dash, which is 1, minus u, which is x, and v dash, which is 2x. All divided by v squared. Okay. We're just going to simplify a little bit. So the top becomes x squared minus 2x squared plus 2 divided by the denominator. And then x squared minus 2x squared is negative x squared plus 2. And we still have x squared plus 2 squared in the denominator. So that is the first derivative. Now I'm going to find the second derivative based on this first derivative. And again, the first derivative is a quotient, so I'm going to assign u equals 2 minus x squared, and I'm going to assign v equals x squared plus 2 quantity squared. And so u dash is going to be equal to negative 2x, and v dash is going to be equal to 2 times x squared plus 2 to the first, times chain rule, which would be 2x, whoops, whoa man, wild, That was a trip, wasn't it? Okay, and then I'm going to simplify this by putting 4x times x squared plus 2. Okay, and I don't know if I should, maybe I should expand that. So like 4x cubed plus 8x. Okay. All right, now I'm going to try to write this into quotient rule. So if I do quotient rule, this will be for the second derivative, right? So v squared is going to be x squared plus 2 quantity to the fourth. Okay, and then I'm going to put x squared plus 2 squared v, and then I'm going to put u dash, which is negative 2x at this moment. And then I'm going to put u, which is 2 minus x squared. And then I'm going to put v dash, which is 4x cubed plus 8x. 4x cubed plus 8x. That didn't come out well. 4x cubed plus 8x. Okay. Now I could simplify the top a little bit, right? So let's see. Minus, and then 2 times 4x cubed is 8x cubed. 2 times 8x is 16x. Minus x squared times 4x cubed is minus 4x to the fifth. Minus x squared times plus 8x is minus 8x cubed. And then it looks like this and this cancel out. And so let me see if that made things any easier. So now we have negative 2x, x squared plus 2 squared, minus 16x minus 4x to the fifth. And that's all over x squared plus 2 to the fourth. And they want to know when this is equal to 0. So to figure out when this is equal to 0, what we really need to know is when the top is equal to 0. So I think we're going to need to expand everything. So we'll put minus 2x times x to the fourth plus 2 times 2. We're using binomial expansion here. It's going to be 4x squared plus 4. And then it's going to be minus 16x plus 4x to the fifth. And then we can distribute this. So negative 2x to the fifth, negative 8x cubed, and then negative 2x times positive 4 is negative 8x minus 16x plus 4x to the fifth. Okay, and now I'm going to combine like terms, so I'm going to combine this and this. So 4x to the fifth minus 2x to the fifth is equal to 2x to the fifth. Minus 8x cubed. Minus 24x. Okay. Interesting. Okay, so basically I have this fifth order polynomial on top. And when I find out when that's equal to 0, then I kind of have my answer, right? So what I'm going to do is I'm going to use polysmlt. So it's a fifth order. Oops. So I go polyroot finder, and then I do order 5, and then I want my real roots. I don't want. Okay, it doesn't let me have real roots. Okay. And that's it. And then I press next. And then I'm going to put my coefficients. The x to the 5th coefficient is 2. The x to the 4th coefficient, there is no x to the 4th term. X to the 3rd is -8. The x squared coefficient is 0. The x coefficient is -24. The constant coefficient is 0, and I'm just going to press solve. And be careful, because do you see how x to the x3 is actually an imaginary root? It has an I there, so that's not a valid answer. X to the 4th is the reflection of that, I believe, so be careful with that too. So basically there's 3 answers. There is the x to the 1st, which is 2.45, and then there's x sub 2, which is -2.45, and then there is x to the x sub 5, which is 0. So those are the 3 possible solutions. So x equals 0, or 2.45, or -2.45. So those are the 3 x values which can give you 0 for the second derivative.